everybody. This is the third video for section 7.2. This is the fourth time I'm doing this video. Each time I've forgotten one little thing, and so I have to just redo the whole thing. But that's okay. We're looking at example number 18. We're talking about the converse of the Pythagorean theorem. So in this problem, we have the longest side is 15. We've got the other two sides are x and x plus 3. We're trying to make this an obtuse triangle. So what we need to do, one side squared plus the other side squared. Because it's going to be an obtuse triangle, when we take that longest side and square it, it will be greater than the sum of the other two sides. All right, so that gives us this equation. So now we're trying to solve for x to see what values of x make this thing happen. So this x plus 3, just going to do this work off to the side. When you square something, you multiply it by itself. And so we get, just doing some FOIL, x squared plus 3x plus 3x plus 9. That's x squared plus 6x plus 9. So what we have is x squared plus what we just did over there, x squared plus 6x plus 9. That's got to be less than 15 squared, which is 2. Let's clean this up here. 225. All right, solving for x. Because we have different powers of x, we got to combine some like terms and move everything to one side, essentially setting this thing equal to 0. So x squared plus x squared is 2x squared. We have this plus 6x, and we're going to be subtracting 225, which gives us a negative 216. Let's go back to the green pen. And that will be less than 0. All right, to solve this, what we're going to do is pretend that this is an equal sign. Okay, it's not, but just to help in solving it and to find these values of x, it just makes it easier. So, to solve this, we got to factor it. There is a common factor of 2. That gives us x squared plus 3x minus 108. And again, just pretending it's an equal sign. Okay, I'm just going to keep both symbols there just as a reminder of what we're actually dealing with. So now, that trinomial, it factors. It is x plus 12 and x minus 9 less than equal 0. So, when we solve these quadratics, when we factor it, we set our factors equal to 0. 2 equals 0. That makes no sense at all. And so that constant that's out in front, that 2, it never affects our answers, but it's there. So, this x plus 12, you set that equal to 0 and solve for x. We get x equals a negative 12. You set your x minus 9 equal to 0 and solve that, you get x equals 9. All right, what we are going to do, because we're not solving an equal sign here, this is an inequality, and this is where it gets a little bit different. It's an algebra, more an advanced algebra topic. I know we solve these things in Algebra 2 trig. You'll solve it in Algebra 2. I've taught it in pre-calculus. I've retaught it in regular calculus. It's kind of a tough idea, but this is what you're doing. Okay, you pretend to set it equal to 0 so you can find these numbers. Okay, negative 12 and 9. We needed to know those. What we're going to do then to solve the inequality part of this, I'm going to put those zeros, the negative 12 and 9, onto a number line. Okay, now these are the x values. So these x values that we're dealing with, these are side lengths. All right, because x is one side of a triangle, it can't be negative. So when we look at this number line, 0 is right here, or so. If you have any value of x that's less than 0, you don't have a side length. So none of these values here make sense. What that means is that we're looking in between 0 and 9. So x value is greater than 0 but less than 9. And we're looking at x values that are greater than 9. Okay, the whole idea of a inequality is that it's a bunch of x values that work for this inequality. Okay, any x value that's more than this, it satisfies this inequality. Any x value that's in between these two numbers, it satisfies that inequality. It makes it a true statement. So what we're going to do is test some numbers. All right, pick a number between 0 and 9. It does not matter which one. So I'm going to pick 1, just because it's a nice clean number. And what I want to know is, does that x value of 1 work? So I'm going to take our equation, that inequality that we had. This doesn't matter which form we use. I'm just going to use the factored form because it's at the top of the screen. I can read it. And we have this less than 0. I want to know, does that x value of 1 make this a true statement? So 2 times. So I'm just going to plug it in. 1 plus 12 times 1 minus 9. Is that, and a little question mark there, is that less than 0? 2 times 13 times a negative 8. Again, question mark, less than 0. 2 times negative 13 is 2 times 13 is 26, times a negative 8. I don't know what that number is, but I know a positive times a negative is a negative answer. A negative number is always going to be less than 0. So that means this x value of 1 that we tested, it worked. That means all of these numbers between 0 and 9 work. That means they're answers to our problem. Okay, and just to check, we got another interval. X value is greater than 9. Pick a number greater than 9. 10. Plug it in, see if it works, just like we did before. So 2 times 10 plus 12 times 10 minus 9. Is that, question mark again, less than 0? 2 times 22 times 1. Is that less than 0? This is 44. Again, I'm fairly certain it's not less than 0. Because 10 didn't work, none of those answers greater than 9 are going to work. And so what this is doing is it's giving us at least a portion of our answer. X values greater than 0, but less than 9. Okay, this is not our answer yet. There's more things to think about with this. The whole question is, what values of x make the triangle? So if we have x values between 0 and 9, it's going to be an obtuse triangle. The other thing that we have to check is, we got to make sure this is even a triangle. Okay, we have three sides, x plus 3, and 15. We got to know, are we using x values that even form a triangle? This goes back to our triangle inequality theorem. The shortest side plus the other shorter side has to add up to be greater than the longest side for this to even be a triangle. So x plus x is 2x plus 3 greater than 15. I need to know what x values make this thing a triangle. 2x, subtract 3 from both sides, you get 12. Divide by 2, x is greater than 6. To even form a triangle, x must be greater than 6. Well, we got a couple of things here. The answer to the original inequality, to make this thing an obtuse triangle, x values had to be greater than 0 but less than 9. To form a triangle, we're saying x has to be greater than 6. So what we're going to do is combine these two inequalities. We no longer can say x has got to be greater than 0, because that includes values like 0.1, 1, 2, 3, 4, 5. We can't have those because then they wouldn't form a triangle. So our true answer is x values greater than 6 to less than 9. You have an x value anywhere more than 6 but less than 9, you have a triangle, and more specifically, you have an obtuse triangle with these 3 side lengths. So our answer is that. There's a lot to these problems. When you come into these problems on the assignment, make sure that you're asking questions and working through. We'll go over them in class. I'm certain of it because, like I said, there's a ton here. And just before I warned this, there is a problem like this on the quiz where you got to go through all of this thought process. The algebra may be a little bit simple, but you have to go through all these concepts. So make sure you're asking questions as you do these problems in the homework. Hope you enjoyed it. Bye.